Good morning everyone and welcome to our video where we would like to present AFL 3 statistics. For our chapters we have 4 chapters. The first one, introduction and assignment. The introduction is done part. And the second part is the cases explanation, testing hypothesis and conclusion for the rest of the chapters. For the group members, we have me, Jonathan Sunjaya, and my partner.
I'm Ilham, Fadhilah Wirayudha. So, why is hypothesis testing is important in business decision? Hypothesis testing supports data-driven decisions, risk management, resource optimization, and quality control in business. It evaluates strategies, informs market research, fosters continuous improvement, and ensures regulatory compliance, enhancing the efficiency and competitiveness. For the first case, we have a one sample test that is population standard deviation is known. So for the question we have is a manufacturer claims that the average lifespan of their light bulbs is 1,000 hours. A quality control inspector randomly selects 36 light bulbs and finds that the sample mean lifespan is 980 hours, with a known population standard deviation of 1,000 hours. At a significance level of 0.05, is there enough evidence to reject the manufacturer's claim? So before we answer this question, we have to go through 6 steps that we have. The first one is to state the null hypothesis and the alternate hypothesis. So what we have here, the null hypothesis is equal to 1,000 and the alternate hypothesis is less than 1,000. The second step is to select the level of significance, which is 0.05. Third step is to select the statistic. Since the population standard deviation is known, we will use the z-test statistic. Here we have the formula. We just insert the numbers from before that is known, and the result is minus 1.20. And for the fourth step is to state the decision rule. For a one-tailed test at alpha equals 0.05 and the critical z value is minus 1.645 from the z tables, if the calculated z is less than minus 1.645, we reject the alternate hypothesis. For the fifth step, we have to compute the value of the test statistic and make a decision regarding the alternate hypothesis. The calculated z value is minus 120. Since minus 120 is greater than minus 1.645, we fail to reject the alternate hypothesis. And for the last step, the sixth step, is to interpret the results. In conclusion, there is not enough evidence at the 0.05 significance level to reject the manufacturer's claims that the average lifespan of their light bulbs is 1,000 hours. The second case, we have a one sample test and the population standard deviation is unknown. The question we have here is about a researcher wants to determine if a new teaching method is more effective than the traditional method. A sample of 25 students using the method has a mean test score of 78 with a sample standard deviation of 10. The traditional method has a known mean score of 75 at a significance level of 0.05. So the question is, can we conclude that the new method is more effective? Same like before, we have to go through 6 steps to answer this question. The first step is to state the null hypothesis and the alternate one. The null hypothesis here we have is equal to 75, and the alternate is greater than 75. The second step is to select the significance, that is 0.05, and the third step is to select the statistic. Since the population standard deviation is unknown, we will use the t-test statistic. As you can see, we have the formula again. We insert it, and we have 1.5. The fourth step is to state the decision rule. Okay. For a one-time test with 24 degrees of freedom, the critical t value at a 0.05 is approximately 1.711 from the t tables. If the calculated t is greater than 1.711, we reject the null hypothesis, not the alternate hypothesis. For the fifth step, we compute the value of the test statistic and make a decision regarding the null hypothesis. The calculated t value is 1.5 since 1.5 is less than 1.711. Again, we reject the null hypothesis. The sixth step is to interpret the results. In conclusion, there is not enough evidence at the 0.05 significance level to conclude that the new teaching method is more effective than the traditional method.
Now, for the third question we have here is the case for two sample tests, independent samples, population standard deviation is known. The question is, a researcher wants to compare the average test scores of two different teaching methods. Method A has a known population standard deviation of 10, and method B has a known population standard deviation of 12. A sample of 30 students using method A has a mean score of 78, while a sample of 35 students using method B has a mean score of 85. Is there a significant difference in the average test scores between the two methods at a significance level of 0.05? Now, as my colleague Ilham stated, we have to go through 6 steps. Now, for the first step, step 1, state the null and alternative hypothesis. The null hypothesis states that mu1 is equal to mu2. The average test scores of method A and method B are equal. For the alternative hypothesis, mu1 is not equal to mu2. The average test scores of method A and method B are not equal. Step 2, set the significance level. From the question, we can see that they have stated that the significance level of 0.05, so we will use that. For the step 3, because it is a two independent sample, we use the c-test, which is where x1 equals 78 and 1 equals 30, sigma 1 equals 10, x2 equals 85 and 2 equals 35, sigma 2 equals 12. Now we will calculate it. We would get approximately minus 0.56 for the z value. For the fourth step, determine the critical value. For a two-tailed test at the risk level of 0.05, the critical z values are approximately 1.96. For the fifth step, make a decision. Since minus 2.56 is lesser than minus 1.96, reject the null hypothesis. Interpreting the results for step 6, there is a sufficient evidence to conclude that there is a significant difference in the average test scores between the two teaching methods. Now, for case 4, we have two sample tests with independent samples. Population standard deviation is unknown. The question is, a company wants to compare the average productivity of two different teams. Team X has a sample mean productivity of 150, with a sample standard deviation of 20 from 25 employees. Team Y has a sample mean productivity of 160 with a sample standard deviation of 25 from 30 employees. Test the hypothesis that the average productivity of two teams is the same at a significance level of 0.01. Step 1. State the null and alternative hypothesis. The null hypothesis is mu1 and mu2 is equal, which means the average productivity of team X and team Y is the same. The alternative hypothesis is mu1 is not equal to mu2. The average productivity of team X and team Y is not the same. Step 2. Set the significance level. From the question, we can see that they have set the significance level of 0.01. So we will use that. Step 3. Calculate the test statistic. We use the t-test for two independent samples. Now for the calculation, we can see that they have produced approximately 1.65. Step 4. Determine the critical value. Degrees of freedom can be approximated using df equals n1 plus n2 minus 2 equals 25 plus 30 minus 2. It becomes 53. Using a t-table, the critical t-value for degrees of freedom equals 50 and at a significance level of 0.01 is approximately 2.63. Step 5. Make a decision. Since minus 1.65 is greater than minus 2.63, we fail to reject the null hypothesis. Step 6. There is not enough evidence to conclude that there is a significant difference in the average productivity of Team X and Team Y. Case 5. Two sample tests, dependent samples. A nutritionist wants to determine if a new diet plan affects the weight loss. She measures the weight of 10 participants before and after the diet. The weights in pounds before the diet are 200, 180, 220, 210, 190, 225, 205, 195, 185, 215 to 200. After the diet, the weights are 195, 175, 210, 205, 185, 200, 190, 180, 210, 195. Is there a significant weight loss after the diet at a significance level of 0.05? Step 1. State the null and alternative hypothesis. The null hypothesis states that there is no significant weight loss after the diet. For the alternative hypothesis, there is a significant level of weight loss after the diet. Step 2. Set the significance level. On the question, we can see that the significance level of 0.05, so we will use that. And for step 3, calculate the differences and the test statistic. We have here all the calculations for the steps. I will just align this minus 1, minus 5.5 for the mean of differences. For the standard deviation of differences, we have 1.58, and for the t-statistics, we have approximately 1 minus 11. Step 4. Determine the critical value. Critical t-value for degrees of freedom of 9 and a significance level of 0.05, one-tailed, is approximately minus 1.80, minus 1.833. Step 5. Make a decision. Since minus 11 is lesser than minus 1.833, we reject the null hypothesis. There is sufficient evidence to conclude that there is a significant weight loss after the diet. So, thank you for watching, and we hope you have a great day, and please give us a good mark.